Here we're looking at problem 18b from our chapter 2 targets. We're asked to sketch the graph of this piecewise function. Now for any value where x is less than -2, we're going to go ahead and use this function 3. So in other words, like you could throw in the point like -3 in for x, and we see that it's less than -2. So then at -3 for our x value, we should end up with a value of 3, because again, that's what our function is stating that it'll come out to be. You could also plug in -2.5 for x, or -2.5. Well, that's certainly less than -2, and as a result, you would end up with the same y value, 3. So at -2.5, we have again 3. And as long as x is less than -2, all of your y values would come out to be 3. So that would happen at -4, -6, and so on. So you would end up then with a line going something like this. Now, because we can get really close to -2, like -2.00001, and plug that in, we would still end up with a y value that's 3, because that x value is less than -2. And as a result, we can come really close to -2 without quite reaching him. And because of that, we go ahead and represent that on a graph as a hole around -2, 3. Now when we're looking in between -2 and 5, well, here it's saying that x can be literally -2. And as a result, at -2, we're going to throw in, anywhere that there's an x, -2. So as a result, we end up then with, at specifically our x value -2, we end up, by throwing -2 into the function, we end up with a y value -2. So at -2, we'd end up again with a y value of -2. And because it can literally be -2, we represent that as a solid shaded in dots. Now we also have other numbers that are in between -2 and +5, like 0. 0 is in between these two, and when you throw that in for x, we end up then with 0. So when we have our x value 0, we end up with our y value 0, pretty much passing through the origin. Just to kind of show it one more time, if you were to plug in -1 for x, again, that's between -2 and +5, well, if you throw that in for x, we end up then with a y value of 1. So at 1, you should end up with a y value 1. Now at 5, we can't quite be 5, but we can come really close to 5. So we're just going to plug it into the function anyway. So if you throw in 5, our x value 5, we end up with a y value 5. So at 5, we end up with a y value 5. But you can't actually be, again, that x value. We can come really close to 5, but we can't actually be him. So again, we're showing an open circle there, because we can't quite be 5 there. And so between -2 and 5, you would just connect all of the points. So you should see something doing that. Moving then on to the last part of our piece size. As long as x is larger than or equal to 5, our y value comes out to be -1. So at 5, our y value is -1. And since our x value can be that 5 value, we go ahead and show a shaded in circle. Now again, if you had an x value like 6 or 7, which are larger than or equal to 5, our y value comes out to be -1. And as a result, at 6 and 7, we have y values that are -1. And as long as x is larger than or equal to 5, we will have a y value -1. So then you should see something like this that would go on forever with that arrow. So that would be then our sketch of our piecewise function. And again, that is example 18b from our chapter 2 targets.